Right, hello everyone, welcome to another stream. How we doing? Right, where was we? Last stream we were working completely not set up right now. Last stream was working on the top level acceleration structure, so being able to get instances of BVHs, so other bottom level BVHs. Up and running, so this will allow us to instance meshes effectively, well, meshes of ellipsoids on the scene. So we kind of got halfway through it, I would say. We designed the, so let's go to the buffer. Shared, right? We designed the BVH instance, which is 16 bytes of memory per strut, and it packs in there like a scale, a rotation, and a translation, as well as a reference to a BVH. So we basically have another tree, a BVH tree, which has leaf nodes of instances, and we've got the CPU build side code, the function that builds them, CPU side, I think those are done. And we're about to try and plug it all in now, basically. So we've got the GPU traversal done as well. So we're just going to start making a... There we go. My laptop's all set up. Welcome, chat. Let's give you a formal salute. Right. So yeah, let's just work on carrying on plugging this in. And if we get time today, I'm pretty sure we will, we're going to optimize the shader a bit because it takes 5 milliseconds to ray trace against a single BVH with like less than 64 nodes, leaf nodes. So it's not very efficient. I have quite a few little things which I'm going to change because I know they're problems, which we'll go over after we get up and running. Because although I'm not doing any hyper optimizations, I just need it to be fast enough to build prototype levels in. But yeah, the even more fun optimizations can come later. Hey Glorious Sir, how you doing? How you doing? Welcome, welcome. Have you been up to much? What have you been up to? So yeah, so memory serves, I need to initialize a buffer. So if we go into graphics internal, if we go into the graphics data structure, there is a new buffer we added. The instances buffer, wasn't it? Oh, it's in the build, yeah. So BVH build strut instances buffer ID. So this stores all of the instances in those BVH instance that we just saw. So we bump allocate those every frame. And I don't think I initialized that yet. So if we go to where the ellipsoids are, leaf indices buffer, neat. So we remember my keystrokes. Let's get these headphones on. Let's get in the jam. Oh, that one failed. Right, so this is the instances buffer ID. And let's give this a nice rename as well. So based on how many... Right. Is this a build thing? Yeah, technically it's not really a build thing. So we do kind of like refresh it every frame, but it shouldn't really actually belong in the build. Strut data. So let's go back to internal. Let's just move it around because that's a little bit silly, I would say. This. So it definitely gets rebuilt every frame. But it could change, I reckon. But yeah, it's not part of build because we could make it actually last multiple frames or something like this and only rebuild it when necessary and maybe apply some sort of global offset. Yeah, like if we have like a tiled map or whatever, you could get to a certain sort of, rather than rebuilding every frame, every time you move to a certain, so many tiles along, then you need to rebuild it. Or if new enemies or new entities spawn in or get removed, then you need to rebuild it. But that's more of an optimization. But yeah, it's not part of the build data. Like it's not. It's more. It's outside of that technically, so we shouldn't really stick it in there. So let's move that around as well while we're doing that. So that's pretty nice too. So let's just so we'll put it here. Right, so we go to this sort of like, there's already this here. Let's just use this. Size of BVH instance. Neat. So now we've initialized that. We've got to quickly locate the other usages of it, I think. So every frame, we're just going to clear this back to 0. So we'll just, we'll bump allocate from the buffer. Right, and in the build top level from CPU data, so we get an array of instances come in. We bump allocate. Just gotta get my keys right. And then we, let's go next one. And then, wait, I got that key. Oh. That's such a good key. Been up to code gen writing for Vulkan buffers and texture initialization. How's been your weekend? Wow, interesting. So you've been... So I guess you have some... You define your resources and you basically automatically initialize them. You define your resources in some metadata, and then with that you initialize them automatically at boot. Is that a sort of system you've built? Yeah, my weekend was good. Friday, I had the nieces and nephews over, and for my boy's first birthday, we took him swimming. He actually didn't really enjoy it too much because of the water for some reason, and the noise was just getting to him. Maybe he was a bit tired as well. So that was unfortunate, but he's enjoyed it before in the past. But we basically just took him to the paddling pool and he was just splashing around like he was in the bath and he was enjoying that. But he didn't really like going in the dinghy and being floated about like before. And then yesterday we had a party and he really enjoyed that. It was basically like children's party but with barbecue and also my friends over as well. So yeah, it was a good time. Everyone had a good time. Ate lots of food, had some really good meat. I got a bit of meat stuck between my teeth. I only just got rid of. Oh, it was so good. Yeah, good times. And someone bought my child some sweets, so I'm doing the honourable thing and eating his sweets for him. This is one. I'll take the sugar hit. But yeah, it's been good. Also had another barbecue today. Went around my family's after church. And Yeah, all was good. So he's got tons of gifts now, tons of toys to play with. Yeah, that's cool. Top level. Yep. Right, so I think we're in a good enough place to start using this now. Can I go through the... Yeah, we're in good. So, where do we initialize... What do we build? Ah, right here. Right. Build from CPU data. And I guess, and the other ones get built at the start of a frame. On the first frame, isn't it? Yeah, they get built on the first frame. We've got a bunch of other models. So one for like a player, one for a tile. Obviously not very good looking ones, but they're just there anyway. So here we'll also open up. I'll do another one. Success equals graphics BVH from... Oh. Just not knowing my stuff. Right. Honestly, I think I might get rid of that auto thing. It's just quite annoying. It just puts a bunch of like... There's so much automatic stuff going on. Editor disable. It's kind of like... Oh, it's hard to even describe what I want to disable now. Yeah, if I do that, autocomplete function. So I'll start typing stuff in. I can't even... There must be a key where I can tap to the next ones. Disable auto complete function args. Yeah, so auto commas, like I don't really care if it being saved like a single key press. So I type the first parameter and the name disappears, but the commas remain. Yeah. Exactly. Configurable in the LSP. Right, and there's a manual on it. So here we go. Also format no. Then the Rust analyzer, it's not really... So yeah, we're also not doing Rust, it's just the Clang one, whatever that is. Yeah, we've got to figure out how to do this. I'll leave it open for later, because... But yeah, future Henry will look at this. Right, so build CPU data BVH ID. So do we have a BVH ID for the top level? Like the scene BVH ID? I don't think we do. So add one in. I decided to try all assets loaded app program start approach without asset streaming system, because I think my game should not be heavy on assets, but I might be wrong. We'll see. Well, I think you're still going to need a streaming system. You could probably load them while the game boots, but you'll stream them in the background while you're still sort of rendering frames for the boot screen. But yeah, oh my days, Egotist, thank you so much. Appreciate it, sir. Appreciate your support all this time. How have you been, sir? Let's give you one of those Bulma salutes. Appreciate you, sir. Less than 3. Less than 3, you too. Model BVH ID is search for that one. Right, so we'll just yank that line, give it a good old paste. And yeah, so scene BVH ID. So we initialize that at boot. Yeah, doing alright. I hope you're doing wonderful. Yes, I am, sir. Just had a just celebrated my boy's first birthday. He's now 1. So it's interesting. 1 year has flown by so fast. So I can see how they quickly become adults. It's pretty insane. So yeah, doing good. Graphics scene BVH. Put in the instances. So I don't want to like destroy my GPU. And I can't really have just one asset or one instance because I haven't supported one for some. I do something a bit unique where I get rid of the root node in the tree and just have the root children. So because I do that, it creates a bit of a funny spot for when you have a single node. I have to do a completely different path. And I haven't done that path yet. So I need, yeah, so we'll just make these instances. So every frame we're going to build up some instances and we'll put 2 in there. And then core array count of instances. Man, I hate auto parentheses because look at these buggers. They're not even letting me, if they put auto parentheses down, why not auto close them when I put the matching one there? I need to turn that off, it's just so dumb. Yeah. Anyway, oh yeah, I gotta try and do all this ain't good. Right, so we're probably just gonna fill them in. Oh no, they can be, yeah, I can just do them like so, right? I can just do a instance in it. So I put in the center position snorm. So they can actually show up really small now, probably. Yeah, center position, sign norm. Make them half the size of the. So we put this one like a little bit down the X or something. Yeah, we'll put them actually diagonally from each other. So we'll just, this one's 0.5. And then there'll be a half width of 0.5 as well. So that will be a quarter of a signed norm area. And then we'll do like a no rotation, the identity quaternion. And then the BVH ref is going to be, we'll do like a tile. Sorry, model BVH, model tile. Neat. So that should now, fingers crossed. Oh, BVH ref. Oh, it's a different thing. So I need to BVH ref. Write that out to do it. So if I repeat that line. Oh. With another tile. This time I do it -5 center position. So we should have two tiles diagonal with each other in the scene. It seems alright. Hey Star Para, how's it going? I'm working on. So we're currently trying to make instances of some simple models that we've made through code. And we are using a BVH as the ray tracing acceleration structure. So we've just built the top level BVH and we're just trying to, well, we're about to build the top level BVH and we're trying to ray trace against it as well. So that's what we're working on today, and then do a bit of optimization on the shader as well, because it's going to be quite slow. And there's like a handful of things I've got to make it better. Oh, that one quickly. Yeah, definitely did. Yeah, load, it should behave the way you described, but there shouldn't be any eviction mechanisms with the approach, which is nice. Awesome. That'd be great. Yeah, so you just have a budget of how much yeah, you have like your min spec, it should hopefully be enough, have enough budget to store your assets in there. That'd be nice. Cool, I've dropped to follow. I'm gonna be looking. Awesome. Yeah, so we're just getting the rendering technology in together. We've done a bunch of R&D over the past 6 months, I would say. You know, built a few different things and thrown them away. And I think this is one we're going to stick with, which would be super nice. And then we're going to probably take a break from the rendering side of things and move into making like an editor so we can build models using ellipsoids basically, and then probably come back to rendering and make things look super nice. Like we've already got PBR, but you'd have to probably get texturing support and other things, which would be good. So in that BVH ray tracer, so rather than ray tracing against a bottom level BVH, we just literally swap it out for that top level BVH. So it's scene BVH ID. Now, I think that's everything, right? Because I don't remember there being any. Oh, and first of all, there's this if-def here, which is stopping my diagnostics from showing up, and I wonder how many of these end up. Meant for shader only, damn it. Yes, the diagnostic. Okay, we'll put that back. Which is a bit. No. It's better because I get the intelligence that way. Yeah, I wasn't getting the intelligence before. Alright, that's good. Okay, so this is the shader code. Yeah, the ray tracer. Was it just the ray trace I wanted to quickly have a look at? I'm just trying to remind myself if there's any issues. Because I think I would have... Right, nothing's standing out. And in the build code, there's nothing really in the build code either, I don't think. Right, let's give it a go and see if it destroys everything. It says build. Right, so if the stream does, we'll be right back. Basically, AMD drivers on Linux especially, they're really bad, to the point where if you have a shader which indexes out of bounds or has an infinite loop, the whole system goes down. But that shouldn't be the case, but it's just a warning. And we've got build error instead. Alright. 2837. Right, I've got the word ellipsoid in there for some reason. It's not really ellipsoid though. Should we call that scale probably? So let's have a look at that pack quad tree. Right, what do we call it? Leave start index, that's what it would have been, isn't it? BVH instances start index, yes, leave start index. Right, pack quad tree. So these two should be a leaves start index, or leaves start index. Alright, does that compile? Right, so now in the ray tracer, ray direction, world space. So direction, world space. Ray origin, world space. 3358. Oh shoot. 3371. Okay, hopefully this is it. Right, BVH node instance index. We should have that. Did I not set that up? So that's in shared. So in our BVH node, if it's a top level leaf, if the type is a top level leaf, BVH node. So is our packed BVH node, it's using 16 bytes. These final 16 bits, if the node type, which is also stored in the node here, if that is a top level leaf, there's the BVH instances index, but it really should be an instance index. So that's probably what I've done. Ah, right. I could just call it instance index. Cool. Right, so in BVH ray tracer, it's missing the field instances buffer. So we need to put that in. Oh boy, we're missing those. BVH instances. So here's our BVH instance. And then obviously when we launch the shader, CPU side, here's the ray tracer. We need to go ahead and copy that line, paste it. So I've actually, I think that's what it's called. Ah, damn it, I just called it instances? That's not very good, is it? Well, I can give that super rename, isn't it? There's a way. How do you deal with pressure in a Scrum sprint as a Java developer? I mean, the pressure created by talking about deadlines and asking how much longer something will take. I don't know if this is specific to Java developers. You know, anyone who's doing Scrum will probably have a similar thing. It really depends on your team. It really depends on tons of things, right? More than just being a Java developer. It depends on company, how your company is when it comes to sort of deadlines, how your team is when it comes to deadlines, what the task is it a very sensitive task? There's lots of aspects that go into it. But yeah, things for me in general, even if, you know, I always want to do a good job. So even if things are relaxed, I always would get, when things go longer than expected, it is quite stressful. But yeah, I don't know. How do you deal with it? I don't know. For me, it's quite a difficult thing to deal with. I think it's probably a difficult thing for everybody to deal with. Like, how do you, you know, tell yourself it's okay, so you don't get completely burnt out and overstressed about work, and then B, how do you communicate in a professional way without coming across too angry, right? It's all difficult things to do, isn't it? Like, because you really, and also like you really don't want to let anyone down, isn't it? When things are going a bit slow, it's just a hard thing to navigate, really. But you got to try and be honest and talk like, well, these are the issues we're having, and get opinions from other people, see what you could do, I guess. Yeah. Because there could be external issues like blockages that are causing problems, like you wait, or you need to maybe work with other people to get more information, or the task could simply just be better in someone else's hands, is more, you know, more aware in that area, has more experience in that area. Hey there, Willie. Well, I guess you came to the right place. How you doing, sir? Alright, let's go rename. Well, back to the vault. Neat. So F key, super F key. So I think 1 or 2 streams ago, I was like, this is really dumb. And I'm asking to get the resource index from an ID, and then I do the sync code separately. So I've done a thing where the sync code just returns you the resource index. Oh shoot, I did the wrong one. I jumped to the wrong line. Sad face. Anyway, so what I can do instead, so this needs to be synced as read only. So GPU command sync resource read only, and voila. So GPU sync resource read only, and the output texture is sync read write, or write only. So we can get rid of this line and this line here. The rest are kind of like globally available, but I have to explicitly sync. I have things to improve in my API still, but that's okay. Right, so I think everything's there now, hopefully. So if the stream dies, I'll be right back, but it should be good. Oh, we're still doing compile errors. Right, shaders are still complaining. Instances buffer. On the ray trace? What? Oh, BVH instances, right. Right, skip against that shader code. Shader code. This is the ray tracer. Instances. So we pull out the instance and then we transform our array, and then we put the root of the BVH tree on the node stack, and off we go. Right. Here we go. Because it's not got the web buffer on it. Fool. Oh. Redefinition of center pos snorm. What's going on? Ellipsoid center port. Right, I guess we can overwrite it. Why do we use that? Because we must transform. Yeah, so I guess we can scope it. So what things will we be missing in these two definitions? So I can then jump to nice. That should be alright, isn't it? Oh, I'm missing this one as well. Oh, damn it. Guess we'll declare these two as well. A little weird. Right. Shoot, I'll jump back in. BI. Alright, local from rotation. Oh, you know what, screw it. This is too much effort. Let's put it back. So we'll just overwrite the local. I think these. To a quaternion? Oh, you put the quaternion first. Alright, let's try that out. Hit T. Oh, Railgen World Space, we got rid of that, isn't it? Direction World Space. Alright, should be it. Oh yeah. Come on. Oh, 2 instances. Do we see 2 instances? This is great. Oh, I've got my other code still running. Right. Things are looking good. When I build the BVHs, so I built the BVHs with, so I think it's in the pack code, pack chord. So I've been trying to get a better packing using like a covariance matrix and stuff, but I'm able to get the correct vectors, not the correct agent vectors. How do you pronounce them? Eigenvectors, but not the agent values. Mess those up, so I can't really get a super nice fitting ellipsoid yet. Not to worry. So I can't move the camera anymore. What did I? What happened there? I wonder, did I move? Is this to do with the ray tracer? Maybe. Is it not the ray tracer might not be using the matrix anymore? But I don't know. You can have a look at the git diff. Hey William. Coding challenge? No. It's not eigenvectors, it's more like eigen. Of course. E. That's always. Hmm. Hmm. Eigenvectors, right. Yeah. Hmm. I guess it could be that. Hard G's. When to hard G or not to hard G? That is the question. Hey very much, how you doing? Eigen vectors. Thank you. I better not look like a Wally. I'll say it like that for now, but I'll wait for the next person to correct me on that one. Is the person called something Eigen then? Who came up with them? Yeah, so did I use the view from whatever matrix? Or from view matrix. Let's git diff my shaders file. Alright, let's have a gander. Where's the ray tracer? So ray tracer. Right, world from view. And I've just deleted that. So I'm ray tracing in view space. Right. So my objects need to be moved from world to view based on the camera CPU side. And then to get the background to move at the end of the ray tracing shader, if we miss, we sample the cube map based on the ray direction. So ray direction world space equal multiply vector transform graphics global view world from view ray direction, and voila. So this will move the background, but the instances are not going to be moved. So I'm glad this works, it's not destroying my GPU. That'll be sad. Yes. So right now we've just got like a nice, baseball cap of soft ellipsoids for some reason, and it's like a first-person shooter game, but someone shot off the other half of my ellipsoids for some reason. Okay. So we're going to get those to move. So in the CPU side, when we build those, so top level from CPU data, I think this is done kind of like after the, let's look for view from, oh, for crying out loud, what did I do? Oh, this is done. Great. Amazing. So we've already got an updated view from world by the time we get to this point. Excellent. So we need to go from into view space, view from world. We've got that as a global. Neat. So what we can do is go back to there. And these things here need to be translated. Now, so the problem is in these BVH structures, everything is in signed norm space. So we need to sort of divide it to get it into that space. I need to have a way where we can create these nicely. I might call it BVH, graphics BVH in it. And it does it. You put in world space coordinates and it will pump out. Yeah, I think I'll do that. So what we're going to do instead is probably make a Now you probably only make these on the CPU anyway. But I think what we should do is grab that. And oh, I want to go into internal. I want to find the graphics BVH stuff, and I'd like to say, "Hey, give me an instance. Give me." So graphics BVH instance of the yeah. So we'll pass in a BVH ID. We'll pass in some center position in world space, and then some half dims in world space. So I guess this would be like a box. So it could be a bit confusing. So maybe I see scale. Right, scale of 1. Because it's not an ellipsoid, it's a box, but in a rotation. This will be a world from local. Wait. Yeah, world from local. Rotation. We go to that line. And then join all these up. Now I think it's a German word like eigen, right? Something like one's own. Okay, I really like the transforms very own vector. Right. Machine Knob, hey, welcome back. I have a question. Does Vulkan have extension to use Float 8? Yeah. Yeah, this is the Helix editor. It's alright. It's pretty good out of the box. I quite like it. There's a few things I'm still having to wrestle with, though. So if you go to GPU info, the Vulkan GPU info, extensions, no, sorry, features. Feature. I'm impatient. Right, it's quicker just open up the terminal, isn't it? Right, Vulkan info, grep, float. Ta-da. Right, AMD GPU shader. No, this ain't it. 16-bit. It could be 16-bit storage. There's a few features. Shader 16, that's what it's called. Shader int 16, and then there's another one for like float as well. They're pretty common these days. I think you can go back as like a 960 has support for it. I think. Just gotta find it. It is in one of these. Yeah, Core 1.2 shader float 16. But I don't know. I'm not sure about the B float. Yeah, it might be. I'm not sure if it is the B float one, and there is probably an 8-bit one as well. Shader 8 in 8. I'm not sure about this. The shader float 8 though. No, I don't think there is a float 8. But you can just do your own, like, I guess you want to like use them as like Yeah, you want to have them as like you want to operate on float 16s and that. But yeah, if you're just storing it into a buffer, like if you're just quantizing it, fit it into a buffer, you don't really need those extensions. Only if you really want to operate on it. But I guess you want to operate it on probably from like machine learning, I guess, because people like to use 8-bit floats for that for some reason. I've heard, but I don't really know too much about that area. Yeah, fair play. That's cool. Yeah, I think I heard people complaining that they weren't around DevDim and software, but maybe they're there now. I don't know exactly about the 8-bit ones. Right, so ultimately we're going to return the center pos snorm. Also going to return half dims unorm. We're going to return some kind of rotation, which should actually be the rotation. And the final one will be the BVH ref. So we'll fill in these local variables, it'll be quite easy. Alright. So the center position snorm. This one is, we turn it into view space. So view space, mole position. So that'll be the G view from the world, right? Center pos world space. Boom. So then we have to scale it down. So there's like a view bounds, view space bounds that we that should probably have. The thing is though, the API you're gonna have is like, well, I've got this thing in world space. Is it should it be rendered? I guess that's a problem for future me to solve, right? I don't have to solve that yet, so we'll just write this API. I'll change it later. But yeah, we're probably going to be having a view space anyway. I don't know. Anyway, half dims view space mol v because it's a vector. ggfx view from world again. Half dims world space. Yeah. So the next one is this sort of rotation, and this rotation is going to be I don't know if we actually have any rotation. Oh, we will. Oh no, we are going to, isn't it? Whoops. Hang on a minute. Rotation. Transform, so we apply. How are we applying that? Right, it's just some kind of like. Right. We need to make a quaternion of that value. View rotation. So we'll just, that's persistent. So let's rename that to GFX view rotation. Is that it? Yeah, good. Yeah, so now it's available, we can do the BVH instance. So we are getting a BVH instance, and the rotation will then be multiply quaternion with another quaternion, and then we need to build a quaternion from. I need to remember my. Shoot. Right. I guess I could do the quaternion from a transform and build a transform from a rotation. What do we do? View rotation. I guess I do that, isn't it? Okay. Hmm. So I call it angle and then quaternion, I guess. From transform. Yeah, so we'll do that. So view rotation angle. Quaternion view rotation quad. Yeah, that's what we'll do. Yeah, so I think float 8 on Wikipedia. I think they list. So there's one of them. Is it on Wikipedia? I remember seeing a list of literally all the values for float 8. I don't know if it's on Wikipedia. Mini float, is that what it is? Yeah. So, okay, this is an example float. Maybe. Example 8-bit float, okay. So I don't know if it is. Yeah. I don't know if it is one of them. But they literally just have a table of all the values. It's not even that big. Hmm. Yeah. Yeah, I've never done machine learning enough to understand how an 8-bit precision is enough. I don't understand that. I thought you need like much more precision than 8-bit float. But that's interesting. GGFX. It's enough only in inference you quantize weights. Oh, right, weights. Okay. I did it again, I just did the terrible naming, innit? So this should really be called view from world angle quaternium. Yeah. Okay, so we're multiplying with the other quaternion world from local and combine them into one quaternion, which will then get put into here. Right. So I just need to then change the snorm, right. BVH reference, BVH graphics, BVH ref from a BVH ID. And I just need to scale these down now. So I need to get like a view bounds. I'm trying to figure out what a view bounds is, but we'll scale them down. So what else am I looking for? Yeah, there's one called view rotation. Right, view from world angle. View from world. Well, I guess I want to do underscore angle then. Right, it's good. So if we go back to that sort of BVH instance function that we're making, nearly there. So we need to make the sort of snorm values. So we need to scale them down. So how do I define the bounds of a view space? Well, not really a view space of the. Let's just hard code it for now. And if it goes any bigger, then it'll just get clamped as well. So we'll clamp things off. Okay, it's interesting. So we want to like essentially do a divide center pos view space by the kind of boundaries. So I guess I can just say like view bounds, but it's kind of like bounds view space. Yep. So bounds half dims view space. So it's not saying the boundaries of view space, but it's just some boundary half dimensions in view space. So I guess I could just say we want to maybe go across the x-axis. Let's say 20 for now. So it's like 40 overall. Then we'll do 10 up. And then we'll do like I guess we'll do I guess we could just keep it even, maybe that's how you do it. Let's say 20 overall. Alright, bounds, half dims. Alright, so that gets you crap. Then we need half dims unorm. So we take the half dims in view space of this sort of instance, and we're trying to squish it down now. So I guess you would divide it by, so if you have like a size of 1, half dims of 1, that is sorry, yeah, we've got to divide it, we're going to either times this by 2 or divide, yeah, we need so imagine this was 0 to 1, for instance, that would be, so say the bounds is half dims of 1. I guess you shouldn't have to change anything, because it meant to be 1 divided by 1. If the bounds was like, okay, 1, and that's fine, isn't it? Yeah, we don't have to change anything. That's good. Okay, so that should be it. Let's use this new function now. So where we were initializing it like this, now we can put in world space coordinates, and everything will just scale nicely. Hopefully. So yeah, we can start using these now. So we're doing a ggfx model tile. So we put 2 tiles down, and we're then putting in some world space coordinates. So we could really make this actually be 1 instead. So they could be 1 apart. And then we could say they're half sizes of 1. So they're actually like 2 big, you know, size of 2 in world space, and then no form of rotation from world from local. Okay, let's give that a go. That should be improved. Now we should be able to move the camera, and excellent. Oh my days. What the hell have I just made? I've made these 2 sort of like distinct, what the crap, viewports. Yeah, definitely that rotation matrix is just messed to the point where it's pretty cool though. Got 2 like lenses. Yeah, graphics glitches are like the best game ideas apparently. But hey, we got instances now. Those colors look whack as well. And the crap did I just do? No. Hmm. Yeah, I think the most confusing one that for me, I can do the world transforms quite. So if you have like a transform that goes between two spaces, easy. You just do the naming conventions, and you're fine. So as an example, here, right? View from world multiplied by world from view. So you basically take the tail end of this one and the head of this one, and you can sort of cancel them out, and voila, you've made a view from local, right? This is easy, but for me that I've still got to try and understand and wrap my head around is when you do stuff like this. I've made an XY translation, and then which way, like if I play the, like in the order of which way you apply the translations matter. Like it could have been the Y multiplied by the X, and that one I can't seem to get my have a way of thinking about that yet. I need to figure out how I want to think about that one properly. World 2 view, right? Yeah. See, I'd say, like, I got this technique from work. Like we do it at work a lot, and my default thinking was to do it, world 2 view, right, with a 2 instead of a from. But the more I think about it, it's like C style stuff is destination and source. It's not source and destination, right? So it's destination source because you have, like with the equal operand in the middle. So the way I think about that sort of from logic is that it is destination source, type of ordering. So the other way around is kind of like anti-C style. So I come to appreciate it being that way around. I don't know what the crap I'm doing here. So yeah, it must be my view. So if I just made them identity, is it the rotation? Well, obviously it's still applying. Wait, there's no obviously. Hang on a minute. Right. Okay, so we ray trace against this, hit the ellipsoid of the. So, right, you can imagine our BVH being something like this, but with 2 less nodes. So we've got the root level. We don't have root level node, actually. We have root children. So we have 2 children. One of the leaf nodes is this whole instance. The other leaf node is this whole instance. Right, and they're both ellipsoids. So we hit the ellipsoid, and the reason why they're getting trimmed is because the ellipsoid is obviously not big enough, and I think maybe our child ellipsoid the child BVH, actually goes out of bound, outside the signed norm range. So it's getting cut for that reason. So really, it's a problem with the model, I think, and not the, yeah. So when we hit it, we then transform the ray into local space. of the object and carry on. So I think the problem is that rotation, like the way I'm doing the, so if I look down, right? No. Right, so after it's hit that ellipsoid, it's messed with the ray direct. Okay, that's what it probably is. It's messed with the. Let's go back to the ray tracer. So we go to the ray tracer. So we've got these sort of things here where it says these are the view space, the top level traversal, and then in local space they are the bottom. So basically we finish the node stack and we wouldn't have transitioned back to view space coordinates. So basically we should, if we've missed, we should be translating the ray direction view space, not just the other local variable. And I get the world space one. I think that's what's causing that lovely lens thing. Right, so we fixed that, that's good. So we've still got like an edge boundary thing and the horrible colors for some reason. I don't know what's going on there. And also, there's the platforms are like rotating. Some weird reason, I don't know why. But yeah, we can look into that as well. Right. Oh, we shouldn't be, the rotation shouldn't be applied. Oh no. Space. I don't know. I did something silly, but so if I were to bring, right, so I think when I build that pack quad tree, so I think actually, so the pack quad tree is when we start the leaf nodes and we traverse up the tree in the shader in a highly parallel way. If we're on a leaf node and it's a top level BVH we're building, I think actually there's another problem, and that is that the half dims so we take the half dims. When do we build this? Yeah, this would be an ABB, so we actually need to multiply it by that square root of 3 thing. It's not the best, but it's required. We need this line here. Yeah, so I think that is kind of missing, but it does, I think, go out of bounds as well. So we still might see a... Oh no. Right, so we made the ellipsoid bigger, and now we're just ray tracing against these things, and there's something else that's wrong now. Oh. There's an ordering. There's a problem in the overlap as well, but... Right, let's tackle the next glaring problem, which is the shading's just really wrong and they're rotating. Let's tackle the rotation problem. They're rotating with the camera. The wrong way around, probably. I think. I don't know. Let's go back to where we... so the ray tracer's gonna... When it hits the top level leaf... See, rotation is like such a dumb name. Oh, does it come from Intel assembly? Not really, because C was around before Intel, wasn't it? So Intel assembly maybe comes from C star, maybe? Column versus row major. Oh, right, so the D3D way is because it's row major, is it? Yeah, D3D is weird because basically in HLSR, they store it in column major, but then all of their functions are in row major. It's bloody weird. Like, so if you program in HLSR, it's a pain in the butt. You have to remember this. So they're constructors and that are all in row major, but it's actually in column major. But yeah, so the initializers are like that. Row 1, it's in the row order. But then in memory, it's column major order. It's bananas. Mm-hmm. Yeah, I tripped up that before. It's horrible. So then apply the inverse rotation. Right, let's have a think. So we're in view space, and we need to rotate back into. Yes, this is going to local to view. The quaternion could be the wrong way around. So maybe. No, because that comes from that angle thing, and that produces this transform. Right, let's just, rather than think, let's just have a bit of a play by not inverting the rotation. Let's see what happens. See what it does. Alright. Seems to be the same sort of thing. So if I don't apply any rotation, that's the next thing to try. What happens there? So where is there some kind of rotation applied? So this is... Crap. Right, so okay, so... The ellipsoids also get rotated as well based on... Yeah, but that's... We haven't got any rotation on those. Let's draw on the outlines, that's alright. That's to draw 3D API, which is different. That's the debug drawing stuff. So this is the bottom level. Right, the hit normal. Yeah, so my hit normal, so this is why the shading looks horrible. The shading probably needs to be brought out of here anyway. But yes, this is why the shading looks horrible, because the normals are all wrong. Probably. Yeah, we're using the Helix editor. Switched to it from Neovim because my Neovim broke. So I rage quit. Yes, the normals are all off, hence why the shading looks weird. But why? So it seems like... Right, so the ellipsoid of the... There's not enough of them to build any like... See, I could put a couple more down. It's not really dumb I'm doing. Let's put a few more instances down. So... Let's manually type these out. 1, 1, -1. Okay, so let's put one that's sort of like... Slow down to the right. Okay, let's give those a go. So I have a few more instances on the scene, and that should give me enough to have a parent. Maybe not though. Maybe not actually. Maybe we need a few more. Let's make one with a negative there. Right, I don't have that one yet. And a negative there, I think. I already have that one. So it's a negative there. Alright, let's give that a go. Hopefully the computer still stays alive. Right, here we go. So we've got a bunch of them now. So if we move backwards, so we should be able, we're seeing like the nowadays so flashy. The normals are all wrong there as well. But these will wrap around their child, 4 of their children. These are the parent ones. So if I turn like that, what you see is that the shapes of the parent ellipsoids around those bottom level BVHs are also changing as well. So it's the whole sort of like tree that's affected somehow. I don't know if it's restoring. Yeah, but how are they getting rotated then? It's bizarre to me. So where do we? So I guess we apply some rotation here. Should we just comment these out as well? Oh, damn it. So let's just call this ray direction. So there's no rotation there. Then here we're going to go ahead and comment that as well. There's no rotation at all. I think now. Right, they're still rotating. Where else is there any quaternion stuff going on? This is the debug drawing stuff. Right, we didn't actually comment these guys out. The other quaternions are there to get the hit direction and that. Right, let's follow ray direction and see what it's doing. Right, so if we need to restore it back to view space, we'll restore it back to view space. So the view space one's just 0 in view space, and the ray direction just goes through the pixels. So that's when we've come out of the bottom level BVH and go into the top level BVH. There are some rotations happening here. This is in local space, and then we ray trace against the ellipse sort of in local space. Then if there's an outline, show the outline, which is different. Right, so this is saying if we hit top level leaf, we set ray direction to the V space 1, and then we scale it down and rotate it, but we've taken out the rotation. If we hit bottom level leaf, we do some shading. But this is just changing the hit position in the normal. But it shouldn't be changing anything to do with the ray. Which change it, like, this is after the hit has happened. Hey, Get Pain, how's it going? Maybe. It's always rotating. Must not be happening because of rotation. It's happening because of the translation stuff that's going on. So the problem is right. No. I think I have some idea what's going on. View from world, and then we squish it down. Yeah, I got to remember I put the... Let's put the rotation back in before I forget that. Right, let's swap these out for world spaces. And let's see if that does anything. So we're not applying that rotate the view from world. They should still exist. Right, they're probably right where the camera is, isn't it? They're moving the camera a bit as well. Right. So we actually have to move them away a bit. Hang on a minute. So we'll actually just make these 10 instead. So I only probably see half of them. Wait. We need to make it 10 on the Z. Because it'll be in view space. So then that means it must be something to do with the rotation of the... Okay. So now they're stuck there in front of us, right? Right. Okay, so re-enable... Doing it from view space. Off. So I'm able to move away from them, right? Correctly. But if we rotate the... You see, if I change it to be the other way around... Inverse... Alright, let's give this one a go, see what happens. I don't think it's the inverse thing. Right, I can't see it. I can't see them at all anymore. Right, so it must be something to do with the shader code, like... So I think this is all correct. So I've got world space coordinates and we move them into view space, and then we're normalizing them, or assigned normalizing them basically, and then making an instance from that. So before... Right, so before we render the bottom level ones, we should just treat them as if they're... So yeah, before we hit a top level leaf and then change it out to be a bottom level BVH, we should instead just render the ellipsoid that represents that bottom level BVH, right? I guess so. And then debug that. So here instead, we can just comment out this line and then just say 1 or this. So just always does this. The problem is the material is going to be what? Oh, it's a global material, right? So we've not bothered. Okay, so we should just see ellipsoids where the others. Right. Hmm. Hmm. Right, I can see why the whole thing's not getting. If we're gonna hit T wrong, it's gonna shade the wrong ones. Let's go back to GFXC and let's remove. Let's remove the extra instances. I don't think they're being a help right now in this debugging experience. But yeah, I can see why we're getting an issue with. Oh, okay, this is good. So are these back now? Right. So these two represent the two instances, but obviously they're just rendering spheres there instead. And as we move around, they sort of get warped. So their position in space is probably fine. Like the way the position gets transformed, it's probably okay. It's probably more of a ray direction thingy. Maybe. Um, See, we've disabled the rotation stuff. Maybe that needs to go back in. Because no. So you've got your ray direction, which would be in view space right now. And you go into the local space of the object. In the so we do have this rotation. It's the view from Quaternion or from local rotation, which is identity right now. I know, could this be wrong? Hmm. Oh, so warm. So you're in view space, and Doing pretty well, just relaxing. Awesome. Good to hear. I just feel this from one angle. Yeah. See, it's meant to be an ellipsoid anyway. Yeah, I feel like the ray direction... I don't know, is it the ray direction that's going a bit odd? Yeah, so we're translating the ray into local space, so it ends up being... No, the ray direction is probably the fine. So take the rotation of the... You know, it might be when we build the tree. This code is probably all okay. When we build the tree, maybe we messed up the rotation. Pack quad tree. Right, so we take the instance data and then build the ellipsoid in the top level BVH. You don't need to rotate the... Right, this could be it. Right, maybe you got to recompute an axis aligned. So this rotation will get you into... Yeah, something's off with this, I think. Computing this ellipsoid. Let's just try rotation is equal to identity quaternion. And let's just... I think the width and height could still be a bit wrong. Nope, it's still being weird. Do we reach this? Like, oh no, we have to because we changed this line of code. And it worked. Yeah, and it made it bigger. Maybe it is the traversal code then? I wonder what we could do to... Maybe we should draw some vectors or something. So, where the mouse is, draw... Nah. It's quite difficult to visualize. Right, so it's not scaling these things. We've already fixed that. Let's remove that. It was doing nothing anyway, but let's just correct it anyway. So, snorm It's not really world space anymore. That'd be unorm. Right, so we translate the origin back and we rotate it. Inverse rotation back. Inverse rotate the redirection. Then ray trace against the ellipsoid in local space. If we hit, depending if we're the parent. Wait, what was going on? Crap. I did a silly. I meant to say 0. That could have caused big issues. Right, so if we're the parent, right. Okay. Right, half dim's world space was that outline. Center pause. Right, it's not really world space anymore. That all needs to change. So that's norm. So it just ray traces against those ellipsoids, and the only type of... This is the only code that's changing the ray. Maybe it's going too far. Maybe... No, I don't think so. So with their world space position, we're moving into view space. That's where they are in view space relative from the camera. And ellipsoid center position, norm. I wonder how it was working before. Because we wasn't doing it in view space before, was in it world space. But but I doubt that's a problem. Let's just like, you know, put view space after here, see what happens. Bit bizarre. Right, still get some odd rotations. So, right, if we look at dead on, you get probably the correct one. If we go to the right, the ray direction should be going... They're going the wrong way? Because that sort of... This sort of... no. Oh shoot, my laptop died. No. Let's get chat back up. You specialize in using hero section from Bootstrap case. What? I've never heard of that. I know what Bootstrap is and CSS, but I'm not sure what you're referring to. Right, it seems like some of the directions are okay, I think. Because like, well, I look up and it looks like the spheres or the ellipsoids, right, are rotating with me, right? I'm getting a, but like, they shouldn't be moving. They shouldn't be moving with me, if you will. A bit confused. I wonder if there's anything we can hard code to figure out what the issue is. So it could be, let's see if we can hard code anything when we build the top level BVH. Hero image from web design refers to a very large, right, attention grabbing picture with text. Right. Oh, that sounds familiar. I haven't done web dev in years now. Right, so when we build the top level BVH and get all the sizing for it, this center position is in view space with a sort of signed norm version of view space. Yeah, it says how do we take it from the local space of the object and move it into the view space position, if you will. Its position in view space. I think that seems all right. And how big is it in view space? And then some rotation from, you know, view from local. We've tried identity on that. Already worked out. Right. So the thing that's getting like if we didn't do any of this, we would not get any movement. The instances will just stay. So if we just use the world space ones here. Yeah, I'm thinking that it could be do with this quaternion maybe being wrong. I don't know, we'll figure it out. Yeah, so we just use the world space coordinates as view space coordinates. So it's just -1 and 1 or something like that we're using. Oh yeah, we'll be inside them. Yeah, whoops. So we'll just quickly shoot over here and we'll put 10 here. Right, positive 10 on both of them. We'll see them in front of the camera, but they're not going to move, right? As you would expect, but they retain because they're in view space. So, right. So I feel like the issues that we're encountering is because of something to do with the things we've done here, or those where they're applied. But where they've been applied worked previously, but it's just this. Yeah, I feel like this is an issue. Here, it's not rotating with the same rotation as this sort of view from world, maybe. So that's causing the problem. This is identity. So let's assume that my multiply function is broken, and let's just try that. Right, so hopefully that works, and then we know it's the multiply. No, still doesn't work. So what about if we invert this? So we do the one of them. Does that fix our problem? Like, is it the rotation the wrong way around? Right, that obviously just changes the rotation to be the other way around. So let's check to see if it's the division stuff that's causing the problem. Why didn't that move? I tried to move the camera. Right, let's move it back to that 10 position. Even weirder what's going on. I have no idea what's happening there. But yeah, well, right, because maybe it was if it was too big. So if you make this 0.1 in size, maybe that will be, half dims. Maybe it might be easier to see what's going on because it's just so big. Right, so here we're getting similar sorts of things, I guess, with this might be better. It's not moving though. Because they're on the edges of the boundaries, maybe, I would say. So let's say 0. Let's just put them in the middle, 0 and yeah, maybe a 0. Shoot. Maybe a 0.1 on the other one. Alright. So our ray tracing sign norm space. So hopefully, right. I'm trying to move and I cannot move. Ah, there we go. So we still have that same issue where, yeah, so well, there's a sort of a squishing of the object still. Okay. So it's nothing to do with, right, we're verified. It's nothing to do with this division where it's squishing it down. We've verified, what else have we verified? It's not the multiplier that's the problem, it's not the wrong way around. So the next thing to figure out is like, is this made correctly? See, translation is just multiplied on the end. I doubt that. I doubt that this is going to fix it. Let's try it anyway. I'm pretty sure I've used that quaternion from transform before, but maybe I haven't. Let's scan the code base for that. Right, so I've used it there. No. Right, I've also used it here. Okay. That's when I was in my eigenvector test stuff. But I never knew if that actually worked or not. But I think it works. So one way to test it would be, let's apply only a 90-degree rotation, but we don't change anything else. So if we say on the y-axis, let's apply a 90-degree rotation, so we'll just hard code it, right? I think it's pi times, which is pi in it. Sorry, 90, pi divided by 2. So let's try that out. Let's see what happens. So yeah, we're looking 90 degrees away to the side. And so yeah, I'm trying to move back. Right, I should be seeing it now, I think, but it's squished up, so I don't think we can see it. So if I have a 90 degrees rotation, what else can I hard code? I was thinking about hard coding this thing here. So if we put our thing at +4, 0 on the Z. So what I could do is actually not hard code it. Oh shoot. I could not hard code this and just check I'm in the right place. So I'll still be looking forward. Yeah, as you can tell, to the left of me is the object. Right, so if I turn 90 degrees to the left, then they disappear. So 10 90 degrees to the left, they've disappeared, right? Cool. So if I hard code it to be 90 degrees to the left, and now we're going to try and hard code this quaternion in some way which doesn't. So just got to figure out what could I use. Right. There's this one. So we try rotation quaternion. I want to rotate along the y-axis by pi divided by 2, right, 90 degree. So let's see if that one works. Right, so I don't see any fix there at all happening to that. Let's do 0, I guess. Would that give you an identity? Maybe. Yeah, but this won't work anyway because... Yeah, okay. Right, so I think this works because it behaves the same way as the other one does. Right, so I guess let's go back to the shader. Let's investigate there. So when we iterate over all the children and we get the center position of the ellipsoid in view space and the half dims and we get the rotation. So this will be x from local, essentially, local from x, whatever space we're in. So space from local and space from world. Sorry, local from space. Because it's any space, basically. It could be one of two spaces. So all we're doing... So what happens if... Oh no, we have to do these. Yeah, so we just apply the rotation. And then we apply the... What happens when we... We tried this right before. Right, first of all, these shouldn't be view space directly. That was me testing something out. Ray direction. What happens if we don't rotate the direction? Was that still causing the same problems? Hang on a minute. Right, so we're not rotating the ray direction anymore. So we're just in the... Okay. So this would just be offsetting the ray origin. Not applying any rotation. I wonder if we can debug draw anything to make it easier to understand. The issue is... The ellipses are staring at me. Staring at you? Yeah, they're a bit weird. It's just so bizarre, man. It's working fine before. Move it to view space. Messed it up. So if we debug draw the rate, I don't know. So basically the ray origin is always going to be the same for every pixel. The ray direction is going to be different for every pixel. The ray direction will be different for every pixel. But we could draw the center one and see what happens. So we could say, given this, and well, we can draw in world space. Draw in world space instead. Is there a game you wish had never existed? Oh. I don't know. Mm, I haven't really got one that springs to mind. Yeah, they're Colt Zero. How you doing? Welcome's lad. So I think we can debug draw. Draw 3D sphere. So we draw a point. Ray, or we draw it in world space, and we're drawing the ray origin local space in world space. Radius of 0.1. Color -1, so be white. Z test, no. Draw 3D vector. Draw in world space as well. We are going to draw the from ray origin local space, and we're going to draw it in the direction of. So it'll be whatever. So this thing here, this local from space rotation. But I want to do it on the on a ray direction, which is good, just going forward in view space. And then I want to do sort of like a 0.05 on thickness and -1 on color and some of that. But I've just kind of messed up this thing here. Alright. So hopefully, I think we might draw a lot of these actually. It could make my system go slow. Yeah. Whoops. I drew one per pixel. Good idea. So we'll just draw it where the is mouse at pixel chord, so I think it's U chord. And we'll just say, hey, if the mouse is over this position, then draw it, so you only get 1 pixel. Let's give that a go. Trying to get back into learning Go. Hey, Quantum Blaze. Seems there's documentation for C# code. Isn't all the way there. There's some stuff that shows both GDScript C#, but some stuff doesn't, right? Technically pretty easy to figure out in some cases. The GDScript versions are lowercase, underscores between them, no gaps, and right. The camel case rather than snake case. Yeah, well, all the C# stuff is kind of new, and they only added it because people were whining it didn't have it. Yeah, GDScript is. I remember I tried out Godot for a bit and I tried GDScript. I wasn't a big fan of it either, to be fair. It's definitely integrated into the engine. But yeah, when I tried to do some programming in it, I was like, this is a bit bizarre. Right, where's the damn... Let's make these a lot thinner. Right, those vectors are teeny now. Whoa, wait. Is that vector going the wrong? No. Yeah, so these represent in local space the ray origin going towards the object. The ellipse they're ray tracing against, and obviously they're going to be right. So they're in. As I look down, oh, as I look down on the object, they look down, and as I look up, they're also looking down. Hmm. Yeah. All right. Now, right. Maybe this debug drawing can help. So these are in local space of the. So the ellipsoid should be at 0, 0 of the scene. So if we draw another one, another sphere to represent the ellipsoid we're ray tracing against, but we'll draw this one at 0, 0 in world space. Ah, debug drawing, saving the day again. Right, this time we'll draw it smaller, and we'll make it like a red. Make it half the size, and we'll color it red. So our vector should always be pointing at the, damn it. Wait, hang on a minute. It's normalized, and it's just a direction, and right, I should probably scale these up a little bit further away. Just by a unit length of 1 away. Or I should scale down this vector here. So if I made this vector 0.01, might be a bit too small. We'll find out. These things. So maybe I should make these spheres smaller as well. Not very easy to see. Great. It's alright. I'll scale these out a bit. So that's a unit length of 1. I guess we could times by something like 8 maybe. Alright, see what happens there. No, should they always be pointing towards the sphere or not? Well, It's hard to really tell. So maybe if we put them like, let's line them up in the middle. Let's put them one down. We'll just put them both on top of each other. They're kind of building an engine with expectation to use GDScript, though I don't like it either. And the performance is garbage for GDScript, in my opinion. Right. Yeah, it was a bit silly how they did all the garbage collection stuff and OOP thing. Yeah, and strange. Right. What am I seeing new? So they've both got, oh, one's -1 back and right. Both in the same place now. So you should only see one of them. Okay, good. So right. This is strange. So as we look up, we're seeing it orbit round. I'm not really understanding exactly like where it's pointing per se, but I could feel like it's pointing like this is pointing past if that makes sense, right? Because this arrow represents the center pixel. So the center pixel has gone past the thing. Yeah, it shouldn't really, but then as we go down, it like the ray, it tilts down as well, and as we go to the right, it's kind of like tilting down a bit. It's a bit weird. It's left, it sort of tilts down a bit and goes. So yeah, there's something up with both the translation of that thing in local space and the rotation of the and that rotation of the redirection, which is the arrowhead. So how that's happening is that there is this local space rotation thing going on. I feel like I'm doing something so silly. So it all could just be down to the rotation. Maybe. So you got this sort of center position in right. Do we need this? Yeah. Because if we don't have this, still doesn't work. But I wonder how it. Yeah, so you're just gonna miss because it just the direction just stays forward, right? And it's not really rotating with the world, with the view rotation. So it's okay. So I have a feeling that there's something wrong with this thing. Because the maths has worked before, right? When we've tried it, I think. Wait, did we try? I don't know if I've tried rotation yet. Maybe this is the problem. Did we try a spinning ellipsoid before? I don't know if we did. Oh. So why don't we make a spinning ellipsoid and just see how... So perhaps the quaternion packing and unpacking code could be the problem. Yeah, I don't remember if I tried it or not. Fully. No, so I remember we tested the packing. But it's got a bit of a weird thing when we look down. We definitely tested something about it. We definitely did test something about it. So when we make those random ellipsoids, it's called like the model tree test. These ellipsoids here, they have a rotation of what? Identity rotation, right? So I think we have not tested the rotation stuff at all. So maybe, right? Maybe the matrix is fine. I think the matrix is fine, but we've got issues with yeah. Right, I got some ideas, new ideas. When we're in the shader, we're gonna test what it's like just have a rotate. When we move the camera, we're gonna rotate. So space from local. We can apply that one and just see how the vector looks. So we'll make a red vector. Hey, like, can you look so far? Anything you missed from the other? There are a few things. So I really do like it out of the box. It's quite good. You know, the LSP setup is nice, and the tree sitter is also in here. You know, I'm still yet to make my own custom theme, but I'm just sticking with Nord, some variation of the Nord theme for now. I really like how you press the F key and you can just jump to anywhere on the screen with just two characters. Or sorry, it's the F key because I've rebound it to the F key. Yeah, the config file is nice. It's just a config file. It's not a programming language. And there's a few little nitpicks. Like I don't have a replacement for that sort of quick fix menu with the make program thing. So I have to use the built-in LSP diagnostics thing, or just run my shell scripts from here and then go back into the editor and manually go to the file, which is a bit painful. And there are a few things with like when you try and autocomplete, it does this where it sort of gives you all the stuff, and you start typing, it just leaves all the commas in. You could probably jump to the next one somehow, but I can't figure it out. And then like, but yeah, I think you can disable that in the language server thing, but I've got to find that setting. There's a few little things out of the box where I need to still change it, but it's pretty good. It's most of the way there. Set point it's kind of pre-set up, and the config file is a lot smaller. And it's more like a modern modal editor versus a it's just more of a new code base with modal. So they try and show a lot of information. So here I've just pressed the command mode, and I can, if I start typing stuff, it will show me all the options. They show a lot of things. Press G, it shows me all the options on the right hand side for the go-to modes. Press M for the match mode, and it can walk me through that as well. I can press Z, it does the same thing. I can also press space and get all the options here. And I can press question mark after pressing space, and I can search the whole command palette. I can find my hotkeys. Be like, oh, what's bound to the G key? And it'll tell me, you know, do what's bound to the F key, and it tells me there. What's bound to the wait? Yeah. So you can, or you can start saying, hey, I want to. You can search for a command and find it, basically. Just quite handy. There's also other things as well. It comes built in with, like, you know, file browse. You know, you can fuzzy search for a file. You can do other things. So it's pretty cool. Yeah. I guess it comes with the documentation stuff as well. I forgot what that is now. It's like a... I forget the key. But I can just search for docs. Right, space K. There we go. Just comes built in with all this stuff. It's quite nice. So I just want to rotate space from local rotation, and I want to rotate just a forward pointing vector. And let's just see how that looks. This one should be in red. Or we'll do green maybe. Right. So that's interesting, right? See here? That v vector, it never goes into the negatives. Well, no, on the y it never goes into the negative. I'm confused. Right, let's build a manual quaternion. Let's say... Yeah, so let's say rotation quaternion on the x-axis, rotate by pi 90 degrees. That should be pointing down or up, up, like directly up. What? It's pointing back towards me? Wait, no, pi divided by 2. Alright, it should be pointing directly up. Or down, okay, that's fine. So if I did negative. Yeah, okay. It should point up, or should I do negative pi, I forget. Right, that points up. Right, so in terms of like, so I guess what we can do is we can do a bit of sine and time. So sine so -1 and 1. Do a graphics global time in seconds. So it should just be bouncing like that, but not really go all the way up. So we're seeing that the rotation works from there. Let's go and make a transform and produce a quaternion doing a very similar thing. So I think we'll try that. So quat from, so we essentially want something like this. Paste it in there. Then I want something like this. Oh, doing that. Okay, so we're going to sine time on the x-axis. Then we're going to drop this y1 and we'll drop the other one. And then we're going to drop that one as well. So this will be our transform. And we'll produce a quaternion. Let's call it R. I'm going to drop R into here. And hopefully that works. If not, I guess we found our problem. But right, so it goes, oh, there's a problem. Right, so our rotation, our quaternion from transform 3D is wrong. It kind of messes up on that negative x thing. What about the, it was to make it like a y one. Is there something wrong on there? Right, at least we found our problem then. I think we have at least. It's in one of the built-in, or one of our core library functions. Yes, the y-axis is just playing us wrong. Look at that. Like just bouncing around. Horrible. Right, so I've clearly got something wrong with this thing. Right, needs. So does look at forward. That's the Z one, isn't it? And up. So if we did a sine and cosine, so let's try this look at thing. and see how it will go. So we try to look at quaternion forward being this sort of like sine thing. Wait. Yeah, maybe my sort of like lookout function is maybe a bit wrong. So you get the three vectors with a cross product, normalize it, dot it, cosine angle. Maybe that won't work. Let's see if we can find an implementation. I might be doing my cross product the wrong way around. No, because that will get you it on the other side. It could be this normalize. No, wait, because that's fine. Flip it. Do you reckon? I'm not sure if that would be it. Based on my limited understanding of maths. Put it back to the X1. Hey Davros, how you doing, sir? Happy Sunday. Right, that one just dings back the other way. Yeah, so that seems... You doing alright? Good. Source point destination, that's the forward vector. Then dot up vector, right. Then if not, it's getting right cross with forward. Right, my rotation axis is probably wrong. No, because if you want to look at, you need an up. Yeah, because how would that... This would surely be funny. Yeah, she's an up vector fix the coordinate system after first rotation. Yeah, you get a roll, isn't it? If you don't do that. Maybe it's my axis from angle code. That could be it. So that's your pointing forward vector. Then front cross with the other forward vector, normalize it. We're not doing that, but that is that there, kinda. Rotation axis. Where's the up vector come into play? Right, if it's that doesn't seem good. Hmm. Yeah, so let's check the axis from angle function. So it's sine half angle, cosine half angle, axis. Right, I've normalized the axis. Right, I normalized the axis. Is that a problem? Probably. Oh, no, it should be. Let's see what happens. Right, does it go down? No. Right, so then they just scale it. That normalize back. And then cosine goes in W. Okay, that seems okay. So I guess it could be my look at maybe? Unless... See, it won't be my matrix, because my matrix is doing the camera just fine. It's able to multiply a vector just fine. Adding compressed texture support to web build. Improvise DXT can... Right. Encoder. Awesome. Yeah, there's texture files. Nice. So like what is that, like a BC3 compressed typically? That sort of thing? Do they support that on the web? Right, see if we can find one. So forward and up vector. These are a bit overcomplicated. Yeah, it's bouncing. Why is it bouncing? So it bounces when the matrix. I guess we can print out what these end up being. So if we manually print out the inputs, see what happens. Or we can draw we could equally just draw the inputs. So instead of drawing R, let's draw rotation axis. So rotation transform axis 2. That would be the Z one, the one that points forward. Let's see how that one behaves. So yeah, it should just be moving down and up, right? So it's just moving like that. Okay, so let's draw 2 of them. And let's see where the problem lies. Maybe both vectors together go different ways or something like this, and it just causes a problem. We'll draw them both green. Right. Yeah, so the up and forward vector are, perpendicular, so it's as you would expect, right? So I guess let's decode some what's going on. So we basically need so let's get the third one, and then we'll so we've got another one, we'll call it axis. That should just be that one should just be perpendicular. So forward. Oh. Forward up. I think it's one of the names S3TC aka DX. Right, aka BC. Right, fair play. Right, so as you can tell, we're getting 3 axis vectors from there. Looks alright. And then, so what's up with the cosine angle then? So my cosine angle is the dot product between these two. That should get you -1. So when you got your forward vector, how much you need to rotate it across? So the axis vector would be the one that's to the left-hand side, and that's what we're going to rotate it around. So we get cosine angle by doing the dot product to get you -1 and 1. And the arc cosine to get the angle. My axis is not changing. So I imagine what's happening is the arc. One of these values is getting absoluted or something. It must be GPU Hprintf. So it would be like angle F comma F, and we'll put in cosine angle angle. So you should see that printed out in the terminal. It's hard to tell. I guess. They're both doing it, I think. Right, so unless this cosine angle. So when it goes that way, it goes from 0.5. Yeah, they both kind of mirror. So it must mean it's the first one then. So this dot product. Right, of course. It's the dot product, isn't it? So it's going to get you like. Okay, so of course they're going to be pointing basically very similar ways. So, so how do they get the angle? There's not the dot product there. But how do you know which way to rotate? Um, hmm. Yeah, so it's mirroring because of this, because the dot product is also same. Like, yeah, it's not getting the right. So the axis, it's as if you wanted to. Hmm. Hmm. Front dot the 2 vector seems weird. Yeah, we're gonna get like a bit of a roll if we don't have the up vector. We roll the camera upside down. We didn't have the up vector, I think. Potentially. Wait, did I get my code from like LinMath by that guy? I wonder if I did. I initially implemented it. Maybe. Maybe not. So that's a matrix. What about quaternion? Did you get it from here? No, I don't think so. Got it from a different place. Hmm. Right, what about... Right, let's see if there's one here. Don't see one. Yeah, I want like a quaternion lookout or something. Yeah, something like this. Yep. Press rotation with specified forward and upwards direction. Z is aligned forward. Wait, not look rotation. Oh yeah. Do something like this. Hmm. Right, what about look? From to... Internal core, okay. Right, okay, what's this? Oh boy. Right, so you got forward and up vector. Normalize the inputs, I guess. Produce a right vector by crossing and normalizing. That's what we've already done. So you got your 3 axis vectors. Cross, and then, okay, so you cross them again to make sure that they're actually perpendicular. Then it produces a matrix, right? And then does it just do a matrix from, sorry, quaternion from matrix then? Is that what it does? Seems that way. Maybe we just do that. Although this would be quicker. Shoot, where am I gone? So I've already got a oh wait, we haven't, this is the quaternion from matrix. Right. Okay, so this one appears to be, there's a thing called num8. Hmm. Right, it's a bit over my head to be fair. But it gets it from this link here. Right, so someone posted an implementation. Take the cross product, then you have 3 vectors to form a rotation matrix. Right. Now you have a rotation matrix. And then how to get a matrix from a quaternion. Hmm. Let's see what there is. Apparently it's that easy. And it can be converted to a quaternion using basic form. But this is only accurate under the certain conditions, and you get The above should work assuming that the function inside the square root is positive. Right, so this is where all those lovely if statements come from. Right. Okay. So basically I don't really need the look at, but I guess we can use the look at to okay. So this all kind of comes from here in a way. This code looks very similar. So it seems like this implementation here, and thus the implementation in that other file comes from this site. Looks very similar. Right, we can give this a go. So it's called like TR. Right, let's give this one a go. Let's convert this over. So this would be the So we should really make our quaternion from transform 3D this code, but I want to make sure the lookat works as well. So for now we're going to stick at the bottom here, but then we'll move it around, I reckon. Best viewers, Let's drop this in there. Man, I can't believe my quaternion code was broken. And that was the problem. Well, hopefully that's the only problem. Right, so the basic idea is you get your forward, you normalize it just in case, right? So I think that should just be a requirement, right? They're normalized. So do the cross product and get the right vector. So vector 3, and then we norm it. So it's basically this thing here, right? How I keep doing that. So we'll just call it the right vector. Alright. So then we modify the up vector to basically just cross product again, so they're all perpendicular. I mean, and you're not getting a really weird looking matrix, I guess, because the up and the forward might not be perpendicular. Yeah, that makes sense. So crossing the right and the forward. Right, then you're producing all these sort of like the matrix manually, right? The rows and columns. So there you go. Then we're going to produce this variable here. Then we are going to produce a quaternion. Could just call it Q. Then we're going to do the square root of this. Oh, these 1Fs are weird. There's another one. Alright. So you got these var things everywhere, a bit weird. I guess they're floats. damn it. Cool, so just got to change the square root. Square root F32. And then all this quaternion stuff, we just called it Q. Alright, so hopefully that should be our right. Up, forward, right. So we get rid of this. Let's try that out. Does it compile? Appears so, so hopefully that works. Right, so I just realized we're not debugging the right thing anymore. We need to be using the look at thing. So we go to shaders. Should be using the look at. Yeah, we're not debugging R. So if we replace this forward with R, and then I guess we can get rid of the other two lines as well. We don't need those anymore. So if this one bounced, oh shoot. We need to manually rotate. Quaternion, wait, mol v quaternion rotation. What are we doing? Bit of time? No, it's already done, isn't it? Just a forward vector. So forward vector 0, 0, 1. Right, so hopefully that works. Right, so it goes down and it goes up. Excellent. So that is what we're missing. So if we now optimize it. So what do we need to do? The optimization is look at is going to call this. We'll delete that, put that in here. So this is going to be t dot axis. The right vector is 0. T dot axis 1, and then t dot axis 2. So that should be right. And then the look at well, you know, maybe maybe it is always best to call that. Nah. Right, so then this one gets the forward, up. Yeah, then it's gonna make a transform. You know, go back the other way. Yeah, we'll do this. This is fine. That one calls that one. Right. So I think we're okay now for the quaternion code. So we probably can just get rid of this. So, right, did we change anything in the instance code? Anything when we make this quaternion? Quaternion from rotation. Okay, it all seems good. Well, I didn't see it working, so something's still a bit bizarre, is it? Right, things are sort of like linking now. Is that because we've got two objects on top of each other or something like this? 0, 0, 1 big. Right, let's try that out. Right, so we've got two objects here that kind of... They're not rotating oddly, they are just... Is that right? They're not rotating oddly? No, they are. A little bit still, I guess. They're weirdly blinking in and out of existence now. So let's go back into the shader. Why would they be doing that? So we've drawn some kind of like... What are we trying to do? Like, are we getting some infinity or something? So if we go back to just drawing the debug shapes, do those things blink in and out of existence as well? Yeah. So I think we're getting some form of infinity, which is bizarre. We're getting some form of infinity with so I assume this. So if we go into the debugger, it'll be easier. So we'll check CPU side first to make sure they're okay. So here we'll just, you know, drop a breakpoint in here. So drop a breakpoint, it's going to fail. Right, okay. Let's run that. Right, so let's print out that rotation. Seems alright. Let's go again. Yeah, we don't know the we should print out the rotation actually just here. Hey Alex, how you doing, sir? You once said that you use C++ in a C-like way currently at work. Yes. Are there sometimes any C++ features you sometimes miss in a C project? Not really. Because I know with any C++ feature, you know, I'll just be tempted to overuse it. You know, with macros, I basically do templates of things, but it's kind of ugly enough that I don't overuse templates everywhere, right? Although at work, I don't usually write templates much. Yeah, I don't know if I really miss anything. I guess it would be templates, if anything. Like a good... But see, the problem is like with most C++ features is whenever you miss a C++ thing, you're actually missing... Like it is so intertwined with every other feature sometimes. Yeah, I don't really miss lambdas at all. I don't really miss any of the OOP stuff. I don't miss any of the strict enum things because the way they do the strict enum typing is just weird. in C++ anyway. What else? Like with references, they kind of silly. So I don't miss those. So maybe templates, maybe. But yeah, equally I can just do templates when I need them anyway with macros. I missed the rusty nums in the match. Yeah, that is quite nice for the pattern matching stuff. It's very flexible, isn't it? Right, I'm going to take this and take it to GPU land and just see what's going on. So go to GPU. And I cannot believe this has been the stream is debugging these things. Bizarre. Right, space from local rotation. Maybe this could be the quantization. But yeah, we have not really tested the rotation stuff, so it's bound to happen. Yeah, I guess the operator overloads could be alright, but you know, people ruin it with those. But yeah, maybe the matrix, the vectors and that could be a bit nicer sometimes. Right, I got an NAN in the W. NAN in my W. So when it's quantizing, messed up. No. So is it the fact that it's messing up because I'm not retrieving the right one? Yeah, so I don't know what's going on exactly. So I could bring this out and then start debugging. Oh, so they're all 1. 1, 1, 1. Right, so then I've done like, okay, so it's done 0. It's been a divide by 0 made NAN. Right. So why are they all 1s? That is the question. It's because they got clamped. No? No. It's not true. Right, let's read the docs. Let's see what I did, eh? So right, 16 and 24 and 0. Right, 16, 24, yeah. Bit of a clamp. Clamp it. 1 to 0. Yeah. Sure then. 24. Yes, alright. So it's got a value of 0 gone in there, basically. So value of 0 has gone in and done that. So I guess what I want to see is like, what is the value here? Is it 0? Like when I do this in CPU code, what happens? Come on. So what happens? So we'll call this a rot underscore, I guess. Rot x, rot y, rot z. So see what these values end up being when they get quantized down. So right now they're like 100 and whatever. Right, so we're on it, 100. Because it's in the middle, it's like a 0.5, right? Bit weird. Because like that doesn't make any sense. If that's a 0. Yeah, that makes sense to be that sort of value. This is a smaller number and that's higher. Oh no, sorry, no, this is higher. Right, but it's still kind of really small. So 0.06. Why is that half of the... Oh no, it is half, isn't it? Sorry, it's -1 to 1. Yes, it's just over half. That's fine. Alright, so then let's do the other code which takes it back. So that'll be this code here. So just reconstruct the quaternion. We'll do it CPU side. So let's call it quat, I guess. So rot x y z. Neat. So we'll print that out. This one was write quat. Alright, see how that looks. Yeah, quat for quaternion. Right, so this quaternion, it gets... Oh, for crying out loud. Let's go to... There's too much stuff in printed out. Let's call this one GP quat. Yeah, I think the quantization's being a bit messed. Right. So CPU side. CPU side, we have this rotation. This quaternion, it gets quantized into these values, which is correct, because it's -1 and 1, so it's a little bit less than halfway. It's an unsigned 8-bit int. So this one's basically nearly 1, so that's nearly all the bits on, right? Then when we you know, when we dequantize, when we restore it back from the quantized data into a quaternion, these are all looking correct, but the W comes out as NaN. So it must be a divide by zero going on or something. So you square z square one take, and it's probably doing a square. You take that away from one, take that away from there. Should be alright. I need to revisit that video again, I think. Now we'll... So if you square... You know, let's square all of these guys. Hey, Cranston, how you doing? Yeah. I didn't realize that I had not tested my quaternion code when it came to doing the BVH ray tracing, and it's bitten us in the butt today. So the first problem was the quaternion from Transform 3D code was messed up. We fixed that after finally figuring out it was that. And now the quantization code seems to not work at particular points. So yeah, just debugging that experience right now. Trying to quantize the, or, ah, shoot. Trying to, oh, what's the result of that? I bet you that's 0, isn't it? Two 60. Make sure it's normalized. Oh. Could that be it? Can definitely give that a go in a second. I just want to print these values out, that's for sure. Alright, let's see what that looks like. So I've squared them instead. And then you add them up and it's basically 1. Yeah. Right. So if I norm... So you're saying if I send it up, it should be normalized. Give me a sec. Rotation. So I might be missing it being normalized. Maybe that's it. No. So we're getting some NANs. Wait. Yeah, we're still getting some NANs. Because that's getting sent up to the GPU as well. Or rather, it's the only value with W that results in a normalized quaternion given. Okay. It could be the fact that my quantization is losing. It's a round up. So it ends up making. Yeah, I think it's because I maybe did a round up when I quantized it. So maybe that results in a. No. Because you lose precision, isn't it? Yeah, I fixed the sign issue. It was to do with my quaternion from transform 3D function. So it was wrong. Yeah, it was very limited. It was basically using a dot product. So when it went down, the dot product value obviously didn't. The two vectors were pointing basically the same way, and the values would be the same as it would go up and down. Yeah, so I had to. Yeah, so my look at quaternion function was wrong. I basically had to build. So this was kind of okay, but I've added this in anyway. You know, you get the right vector and then recompute the up vector so they're all perpendicular from each other. As you've got your 3D matrix, and then there's this code that I found on the internet where it converts a 3D matrix to a quaternion, and it's a bit fiddly, but it's possible. Yeah, so this handles all the edge cases apparently, so that's nice. So yeah, I use this now. One thing people mix up is interpreting x, y, z sometimes as all angles, i.e. x in degrees. Right. However, around the x-axis, so whatever around the x-axis, or y around the... Yep. When dealing with quaternions, the interpretation needs to be different to find the axes of rotation. And then w is how much by, right. So it's like a normal, if you will. Would you say it's like a normal and then you rotate around that? Yeah. That's cool. Yeah, we're not really thinking in... Well, I'm not really thinking in that terms, I think, for this issue. Yeah, it's mainly like... Yeah, I always forget about you have to normalize them, though. But yeah, something to keep an eye out on. It's something to do with this quantization code. It's a bit of a bugger. But yeah, I think... So we bring that line back where we sort of just print out... what is that? Seems a bit bizarre. It seems a bit bizarre that we're getting a... Is quat and it says 0. Well, square root of a very small... Because these are not showing. and is 0.0868. So it seems like it is there. So, when you square root that number, is it just that small? Like, if you put that into Google, they obviously give you a number, right? So, like, what's the problem? X or Z is a bit more if the rotation axis multiplied by sine of half angle. Right. Okay. W is not the angle though. The rotation is encoded as sine angle times normal. Right. Cosine theta times 1 length of... okay. Right. Interesting. Crazy. Yeah, divide by 2. Right. Right, so for some reason I'm not getting NANs anymore. So what the crap went on there? Why is it then that this gives me an NAN, but when I do this, it doesn't give me an NAN? Bwom, bwom, bwom. And this is CPU side code as well. It's not my custom compiler. This is in Clang, and it does the same thing on my compiler as well. So, bananas. So if I try. Ooh. So they're all just set there, and we just use them here. So let's just show that it's being weird. Let's add another one. We'll put 2 after it, and then we'll right, so oh, they're not showing up in AN anymore. Like, what's going on? I'm confused. Right, so it's just the GPU ones are showing up as NAN. So I've probably... Wait, why are the GPU ones NAN? Okay, so we're able to quantize it and then unquantize it, just find CPU side. So what did I change which was different? I've not done the round up anymore. Right, what do we do? Let's put the round up back in there. Does this produce NAN CPU side? Right, CPU side we've got an NAN. So if I were to redo that, remove the round up, that fixes it. Yeah, I'm not seeing any NANs. Alright, so it's that round up which was the problem. So let's go and fix that. So shared, when we quantize the stuff. We shouldn't be doing the roundup. Whoops. It's past me being silly. Right, so hopefully that gets rid of the flicker. No. Alright, so yeah, the GPU values are still different somehow. What else did we change CPU side? I don't think I changed anything else. So yeah, these ones are really wrong. So I think that is maybe we're not extracting the values back correctly. Maybe they're being ORed with well, the fact these are clamped, which means they shouldn't go past the integer when multiplied. Same with these, which are the neighboring ones. So they shouldn't be overlapping. It's 14 bits, isn't it? Yeah, I guess let's read back the values and compare them. So in the GPU code, we want to basically be doing something like, where is it? This. Well, yeah, we want to manually read back and print out something like that. So let's go into shader. Where are we doing this? Oh. Yeah, so here we're just going to paste this in. So where's the instance? Is it an instance? Oh shoot. But yeah, it's like we're yeah, it's just node, isn't it? Node word 2. Right, so we take those, we extract them out. Yeah, I really just want to read these actually. So let's just say GPU rot. Right, so 24. Then this one is 24 and 0. Right, so hopefully, I didn't get any of that actually. Hopefully those are the same. Fingers crossed. Right, so GPU rotation 0 when... Okay, so they are actually wrong. Painfully wrong. So we've packed them in and we're not getting the same values back. I wonder why that is. Oh, wait. Nope. One of them is fine. Yeah, it's kind of like a frame late, I think. So we run it, just keep it still. Memory scale double coordinate should be cosine. Yep. Sounds correct. Huh. So CPU side, we upload this one. And we're seeing it repeated here. Great. V sharp correct. But the second one, and it comes back wrong. It could be because the bits can't get overwritten. They get an odd. So I don't know why that would show up that way. This getting odd, so this shouldn't show up as 0. Right, so they're all showing up as NAN there. If we see here yeah, this rotation just doesn't even map. Oh no, it would do that though. Yeah, there's a bit of maths where it negates it. But yeah, they show up okay. So they're basically the same, give or take a margin of error. But it still shows up NAN. So this is the case when it flips the okay. Right. Yeah, so you add those and it will overflow. Damn it. Will it? So that's to do with when we pack the quaternions. So, oh shoot, I've just realized I changed it in the BVH instance code. Wait, is this what we want to do? We need to change in the BVH node code as well. Remember now, it's a copy and paste. Yep, so this is what we're seeing is that when W is negative, we negate everything else, and then we can drop the component and recreate it, hopefully. Right. So we'll be creating a sort of a negated quaternion. But yeah, we've got to try and recreate that. Yeah, so this is where it happens, right? No? That just makes an NAN without flipping it at all. Right, sometimes those are ending up flipped. It's a bit weird. But here, W is not even negative. But when you read it back on the GPU, it's flipped. It's flipped the XYZ, and then the um. Hmm. So the problem is the instance thing gets turned into a node in the shader code. Pack quaternion here. So it's extracting it and then it'll re-quantize it back down. But I don't think it's doing anything special with it after. It's just sending it straight back into BVH node in it. And quantizing it back up, which is a bit bizarre. Right, so it would have recreated the W, and that would have been wrong. Or something. Or different, yeah, okay. So I think what we're getting here is we're creating the instance, the instance then gets turned into a node on the GPU, so that recreates the W component. That ends up being slightly wrong, and then we're seeing it be negative or something, and then it will store it in the BVH node, flip everything around in there, and then when we read it back it'll be flipped, and therefore it'd be NAN. So yeah, we need to just solve the problem where now when we flip it, for some reason the W becomes NAN. Maybe we have to renormalize the vectors. After no. Right, I think I might put a pin in it there because I'm getting too tired now. But yeah, something to do with these quaternions needs fixing still. Need to have a think about it. Maybe this yeah, we'll have a play next time. Right, so next stream will be on Tuesday at 7:30 p.m. GMT +1. We'll hopefully we'll fix up these quaternions and get on to finishing up on the ray tracing against the top level BVH. Hopefully this is the last bug, but we'll see. I was on audio only for a while, so I might have misunderstood, but are we packing the quaternions into 3, not 4 integers? Yes. Wait, or is it just we're storing W in a separate? No. Yeah, so we're packing 3, the XYZ of We're packing x, y, z of the quaternion into 8-bit integers, and then reconstructing the last component when we unpack it. So we unpack x, y, z, w. So we unpack x, y, z, reconstruct w. Because for w, it's apparently the square of x, square of y, and square of z all add up to 1, and the w is just the remainder of that. You have to square root it for some reason. Maybe I don't need the square root. Maybe that's the problem. Yeah, I'm not really that sure about my quaternions. Yeah, this is what's causing the 0, but I think... Right, it's just creating some really funky artifacts. But maybe this is not... Right, we're seeing the... Right, we need more resolution. We can see the JIT. But yeah, that square root is causing a problem, I think. But if we take away the square root, it does kind of fix it, but I don't know. We're getting weird halo looking things. Oh, we're getting a 2 there. Yeah, that ain't good. It needs to be... Oh. Square root. Take sine. Theta root over 2 equals... Theta. Right. Yeah, I think it could maybe be the quantization. That's sort of like... So it'd be rounding down. No. Rounding down should be fine. Yeah, it should be... You should never produce a 0 from that. Yeah, a bit bizarre. But yeah, I'll try and solve this next time. Right, so next one on Tuesday and Thursday at 6:30 p.m. GMT +1. This first one's very quick. Gonna go and relax for a bit before bed. Hey, Startup Era, how's it going? Oh dear, just gonna crash. You know what, let's just turn that stream off. Thank you. I will do. Alright, I'll see you on future one, guys. Thank you for coming by, thank you for the help, and catch you later.